back in the shop, and we're getting ready to chamber this 6.5 by 55 barrel for the Kimber rifle. So of course the tools we'll use are the same as with most anything else. We have the chambering reamer in its homemade wrench here, and the Go headspace gauge, the depth micrometer, and we'll rough the chamber with the common twist drill. This one, 27/64 bit, which gives me about 15 thousandths of an inch or so to clean up with the reamer. And so when I'm using the twist drill, I can drill in just deep enough. I want to be sure that the pilot will still engage, and so in this case I can drill in about 1.5 inches. This reamer looks like it has an integral throater, but it really doesn't. The throating portion has been removed, and so with this one we'll be cutting the throat separately. Now, as I said, I can drill in about 1.5 inches, and then hopefully the reamer, that'll leave enough for the reamer to clean up. When I drill in the first time, I go about 1/2 inch at a time with the drill, and when I drill in the first time, I'll check after drilling in the first 1/2 inch, just to make sure that the diameter, that the drill isn't drilling oversized and surprising me in some way. So what I'm going to do now is we're going to move the camera so that you can see the operation a little better. So there we are, the camera's in place up in the perch, and so we can commence. Now, before I started here, I let the lathe run for a while to warm up the headstock, and that ensures that the headstock and tailstock are at the same level, because otherwise when the headstock is cold, it sits a little bit low. In this case, I think about 3 thousandths of an inch. When you're drilling, it doesn't hurt to push that drill bit a little bit. It actually helps it to align. And I'm just going to check. Sure enough, it's drilling right on size, so we're good. And I think I just went in 1 inch and 1/8, and we're going to stop there and just see how things work out. Now, one thing that I'm going to do is just to our dial indicator. And just check And that's showing a total indicator run out of just about a quarter of a thousandth of an inch. Which just isn't all that bad. So now, if I'm doing a chamber for a bench rest rifle or a match chamber, generally speaking, you know, for shorter cartridges, then I'll pre-drill the hole just a little smaller, and that pre-drilling is as much as anything to allow me to reach into the throat with the dial gauge, and then I'll dial in right at the location of the throat, and then I'll bore with a little boring bar. I'll pre-bore the chamber and then ream it. But for a hunting rifle, the truth is that the drill does a remarkably good job, and the difference isn't significant. Now for reaming on this, I'll generally run it at 90 RPM. So I engage the back gear. There we have it. Then I just use the dip and squirt method for oiling, and I have used flow-through systems, and they work very well, but I like to pull the reamer out and check quite often anyway, so this works fine for me. Now again, for the first few cuts with the reamer, I don't mind pushing it a little bit, and the first cut I'll usually ream in for just about a ½ inch or so. We're getting a good finish. The reamer's clean, and so we'll continue on. Now Now to start with, I support the reamer on the center in the tailstock. But after I've gone in a ways, I can switch to a pusher that that allows the reamer to float a little bit. But really, that float shouldn't be necessary if the setup is good. Okay, here we are. As you could probably tell, I paused the camera while I reamed most of this, because watching me cut the chamber is kind of like watching grass grow. But anyway, now we're getting down to the end of the chamber, and I've got roughly 45 thousandths or 35 thousandths of an inch to go, and so I'm going to cut 20, and then I'll finish the rest on the last cut. Now, as I get down to the end, and I'm sure I've mentioned this before, but as I get down to the end, I after every cut, I check the edges of the reamer to make sure that they haven't picked up, had any chip welded to the edges. And there's one. There's a little bit of a catch there. So then what I do is I take this little piece of triangular stone, and I just stone the face on each flute, and I'm not sharpening the reamer or anything of the sort. All I'm doing is removing any little chips that might be welded onto the edge and which might score the chamber. And in case you haven't caught on, that would be bad. And so I clean these off, and for the last 5 or 6 cuts I'll do that, because early on in the chamber, if you get a little bit of a mark, it's not a big deal. You clean up the reamer and you've got some more to cut, and generally speaking, the taper of the reamer will allow you to remove that mark. Now, with a short cartridge like a PPC or a BR, which are quite straight walled, you can't get away with much of a mark, and so you have to be a little more careful. And the same thing goes to even somewhat larger cartridges. Any of your improved cartridges which have minimal body taper are a bit of an issue that way. You want to be very careful not to get a mark in the chamber early on, because if you do, the reamer won't clean it up. So anyway, here, as I said, I'm going to cut about 20 thousandths of an inch, and then I'll be ready for the last cut. Now, I didn't go to the pusher on this particular barrel because there's virtually no run out anyway, so it wasn't necessary for the reamer to float. Now, also on these last cuts, of course, the reamer's cutting full length on the body, and it's cutting fully on the shoulder and neck, so that there's a little more pressure there. And because I want a good finish on these last cuts, I feed it quite slowly. go. Clean that out. So our headspace on the action that we're working on, the distance from the face of the action to the bolt face, is 859 thousandths, 0.859, and I've made the tendon on this barrel 0.888 long. So the gauge has to sit 31 thousandths below the face there. And earlier on, I think I had mentioned the number 17, but I actually took a cut on the shoulder after that because I wasn't happy with the finish. And so it's up to 31. And right now we are at 13. So 18 more thousandths, and that'll be it. And in actual fact, I'll go 20 thousandths because, as I think I've mentioned, I like to give it 2 thousandths of an inch for crush. When you tighten everything up, you'll usually gain 2 thousandths of an inch. And so there we go. In there. And again, check the edges. Should be pretty clean. And they are. Push that in until it contacts, lock it down, and then slowly cut our 20 thousandths of an inch. Ten. 15, 20. When I come to the end, I generally let it dwell for a couple of revolutions, and so that should be that. Let's see what we get. Well, I was looking for 33. I've got 32 and a half. I'm going to call that good. And so there we go. Now, The next thing I'm going to do is to cut the throat. And as I'd said before, we're going to cut the throat separately on this. We're done with the chambering reamer, so I'll put that away. And I'm going to pause this while I get the throat around. Okay, this chamber, as cut, has no throat, no free bore whatsoever. So, in order to determine, how long my throat has to be, I just take a cartridge with the bullet seated the way I want it, and I can put that in there, and I can measure, and there I get 230 thousandths plus 30, so 260 thousandths. I think I'll just cut it at 250 at a quarter inch. Now, when I do that, just a couple of points. I just go in with the throater just to roughly tell where it's going to engage, which is right there, just so I know how far I can push it in before I have to start paying attention. And but the other thing is, this is a 5-groove barrel, one of the 5 R's that have become so popular in recent years. And when you're cutting the throat separately on these, it can be kind of hateful if you're using a 6-flute reamer, especially one that's with straight flutes, because they get pushed off by the lands, and there's no support on the other side, so the reamer kind of jumps back and forth, and you don't get a true diameter cut on your throat. So so for the 5R barrels, and well, for most of the barrels now, I have all spiral spiral fluted throaters, and that way they're supported because the flutes are in a spiral. They're supported as they cut, and they do a fine job on the 5-groove barrels. On 3-groove or 7-groove, it's not an issue because there's still enough support for a standard straight fluted 6-flute reamer. But as I say, with the 5R barrels, it is an issue. So anyway, and to do this, reach up in there and give it a little squirt. And go in there, and then it's just a matter of feeding that in until it touches, and you can readily feel when the reamer makes contact. There it is. So from this point on, I'll go my 250 thousandths. I'm at 26, so each turn of the wheel is 125. And there we go. And that's, I'm not going to stick that in there hard, but that's just fine. It's clearing. It seems good. So there's the throat. So now the next thing on this particular barrel, of course, is to cut the coned breech. And so to do that, first thing is to strip the bolt, rid of the extractor, and the collar. And then I just take a protractor and double check the angle. I believe they're a nominal 45. Or in this case, oh yeah, I believe that is a 45. So yes, 45 degrees. So then the drill is to just set the compound over to cut the 45-degree angle. So and another pause while I hunt up a tool. Okay, so now having roughed in the 45-degree cut, I put the stripped down bolt in the receiver and put it in the locked position, and then I just screw that up until it makes contact, and then at that point I can just use a feeler gauge to see just how much gap I have left. And I cut this one pretty fine. So let's see where we're at here. As I said, I cut that one just a little bit close so that I've got well, I've got about 5/1000 of an inch, I think. Make that 4. A tight 4, so almost down to 3. So now you want to end up when you're done with about 5/1000 of an inch, between 5 and 10/1000 of an inch of end play between the bolt and your coned breech on your barrel. Any tighter than that, and you risk a situation where you get a little bit of debris in there and the bolt won't close. So right now we've got 4/1000, which would give us 0, and so if I cut another 9/1000 of an inch, that'll give me 5, and just as with the chamber, I'll give another 2, so we're going to go 11/1000, which should give me 7/1000 of clearance, and when I tighten it up, that'll be down to 5, so we'll see what we get. Now, to do this, I'm just going to go in and touch, and then I'll use the dial gauge, which I can set up here, I believe. And I can let that run against the carriage so I know just how far I've moved. And see if we can get this to sit the way I want it to. There we go. Here I can go up and touch. And then if I go in 11,000ths of an inch on the gauge, that should work out. So let's see what happens. That little polish with some 240 grit paper, cloth. Now I'll screw this on and see what we've got. Snug, and then I can just check the amount of movement with the caliper back here. Maybe I can get past the. It's a little different. So now 1.432. There we go. Yeah, I've got exactly 7/1000ths of an inch of movement. So when I tighten that up, that'll reduce to 5, and Bob's your uncle. So anyway, that's that part. The chamber is finished, the throat's finished, the cone and breech is finished, and for right now, we're finished. In the next video, I'll show how to set up with the Palmgren milling attachment to cut the extractor slot in this, and then it's just a matter of doing the external finish work, marking the chambering on the barrel, and this one will be done, and then it's on to the next one. So until next time, this is Will Henry, out.